go to our next section, 2.7, transformation of a function. So the transformation of the function, I just lay out the property here. There's 6 of them. There's only 6 here you need to concentrate on. So let's look at the property here. Let's say they're giving you y equal f of x. The first one said that if you have y equal f of x plus d, so you add some constant into the function. It tells you that the graph will shift that constant upward that units. So let's look at our first example here. I have f of x is equal to x squared. This is a parabola open upward. I make a table here. So if x is 0, 0 square is 0. If x is negative 1, negative 1 square is 1. 1 square is 1, negative 2 square is 4, 2 square is 4. So I graph it here, 0, 0, negative 1, 1, 1, and 1, and so on. So it's going to be a parabola open upward. Now I'm going to add a number to a function. I add 1 to it. So f of x is equal to x squared, and I add 1 to it. So it's going to be x squared plus 1. So if you plug in a number, if x is 0, 0 squared is 0, plus 1 is 1. If x is negative 1, negative 1 squared is 1, 1 plus 1 is 2, and so on. So I create a table here for you. But let's say if you want to graph this. So if x is 0, y is 1. If x is 0, y is 1 is over here. If x is negative 1, y is 2, negative 1 and 2. If x is 1, y is 2. If x is negative 2, y is 5. Somewhere here, and f is 2, y is also 5. So your graph will be the blue one right here. So as you can see, the blue graph is shift 1 unit up from the black one, as the theorem mentioned here. I add 1 to it, and the graph shift 1 unit up. It's like you pick up the graph and bring it up 1 unit. All right. So let's look at number 3. All right. You just practice number 2 yourself. It's going to go down 1 unit. Number 3, I add a constant into a variable. Make sure it's 2 different things. This one I add a number to a function. This one I add some number to a variable. So what I did, I add 1 to x. All right. So my function is x squared. So I'm going to have, instead of x, I'm going to replace all the x with x plus 1 square. And then I make a table here. If x is 0, I have 1. 1 square is 1. If x is negative 1, I have 0. 0 square is 0, and so on. So let's graph this. So if x is 0, y is 1. If x is negative 1, y is 0. If x is 1, y is 4. If x is negative 2, y is 1. If x is 2, y is 9, up there somewhere. So my graph looks something like this. As you can see, the blue graph is shift 1 unit to the left. So I add 1 to my variable, so it shifts 1 unit to the left. All right. So same thing, if you subtract 3, it will shift that many units to the right. So let's look at number 5. Number 5, if y equal to negative x, f of x, then a reflection, it would be in the x-axis, and x minus y is the point on the graph. So I'm writing y equal to negative f of x. So my f of x is x squared. So I'm going to have negative x squared. So if x is 0, I'm just going to have 0. If x is negative 1 square is 1, but you have negative up front, so you're going to have negative 1, and so on. I create a table for you here. So let's see what's going to happen. As you can see, this is a parabola open downward. So let's see, if x is 0, I'm going to have y is 0. If x is negative 1, y would be negative 1. If x is 1, y is negative 1. If x is 2, y is negative 4. 1, 2, 3, 4. And x is 2, y negative 4. So it's going to be something like that. So as the theorem said, it's going to be reflect about the x-axis. Alright, so I want you to concentrate on these six definition, and I will see you next section. Alright, let's go to our next section, combining function and composite function. So combining function, you're going to have two functions. You can add them, subtract them, multiply them, divide them. When you divide, make sure that denominator is not equal to 0. So let's look at combining function first. I have two functions. F of x is equal to 2x plus 1. This is linear. G of x is equal to 2x squared minus 3. This is parabola, quadratic parabola, open upward. Let's say if you want to add them, so you're just going to follow the definition here. It said that f plus g of x is equal to f of x plus g of x. So I'm going to do f of 2 plus g of 2. Just follow the definition here. So I go to my f function. Instead of x, I put 2. So I'm going to have 2 times 2 plus 1 for the f of x, or f of 2. Now the g of 2, I'm going to go to the g function. Wherever I see x, I replace it by 2. So I'm going to have 2 times 2 square minus 3. Alright, so 2 times 2 is 4, plus 1 is 5. Plus 2 square is 4. 4 times 2 is 8. 8 minus 3 is 5. So it's equal to 10. So just follow the definition. The second one, multiplication, this is number 3. So it's equal to f of 2 times g of 2. That's what the definition said here. So you go to the f function, replace the x by 2. So you're going to have 2 times 2 plus 1 times the g function, go to the g, replace the x by 2. Again, I have 2 square minus 3. So it's going to be 5 times 5, which is 25. Alright, it's pretty straightforward. Now the composition, look at the composition is a function inside a function. If you have f of g of x, so the one that next to x, it will be the inside function. So let's look at our first example. They want you to find f of g of 2. So if I gonna rewrite this, it's gonna be f of g of 2. The g function is the inside because it's next to the constant here. So I'm gonna have f. I'm gonna go to my g function, which is this one. I'm gonna replace all the x by 2. So I'm gonna have 2 square minus 3, which is f. 2 square is 4. 4 times 2 is 8. 8 minus 3 is 5. Now I have f of 5. I have to go to the f function, replace all the x by 5. So I'm going to have 2 times 5 plus 1, which is 11. Alright, let's look at the next one. The next one, instead of f of g of 2, I put g of f of 2. So now the f function is the inside of the g function. So you're going to have g of f of 2, right? So you're going to work the inside first. So go to the f function, replace the x with the 2. So I'm going to have g of 2 times 2 plus 1, which is g of 5. Now I only have the g function. I'm going here, replace x by 5. I'm going to have 2 times 5 squared minus 3 is 2. 5 squared is 25. That's 50. 50 minus 3, which is 47. All right, let's look at the next section. Hey everyone, let's go to our last section of chapter 2, the inverse function. All right, let's to have inverse function. So the first one-to-one function, a definition of one-to-one is that each y value in its range correspond to only one x value in each domain. So that's the definition of one-to-one. Another one is if you draw a horizontal line is good from left to right, then it should cross the graph one time, not more than one time. And another one is if you take the function and its composition, you should get x back, or do the inverse to the f, you should get x back. Let's look at our example here. I have f of x is equal to 3x minus 4. We want to find inverse function of this and then verify that the inverse is the inverse of each other. To verify that it's inverse, you have to do the composition. Right? So let's look at my function. I have f of x is equal to 3x minus 4. So I'm going to write it as y equal 3x minus 4. Now I'm going to solve for x. So I'm going to have y plus 4 equal to 3x. So my x would be y plus 4 over 3. I'm moving a little bit. So my x would be y plus 4 over 3. So next step I'm going to interchange x and y, which means x become y and y become x. So I'm going to have y equal to x plus 4 over 3. Then I'm going to replace y by the inverse notation. So the inverse function is going to be x plus 4 over 3. So that is my inverse function. Now I have to verify that this is the correct one, it's the inverse of each other. So you have to do the composition both direction, right? So let's do that. So first I'm going to do f of f inverse of x. So the inside function here is the inverse function. So I'm going to have f, the inverse function is over here, is x plus 4 over 3. Now I have to go to my f function. Instead of f of x, I have f of this whole thing. So I'm going to have 3. Instead of x, I have this x plus 4 over 3 minus 4. Alright, so I can reduce the 3 here. So I end up with x plus 4 minus 4, which is x. So I show the one direction. I have to do the second, the opposite as well. You can't just do one way, right? So, and I'm gonna show the second, the reverse, which is f, the inverse function of this. So now the inside function is f of x. So I'm gonna have f inverse of, my f of x is this one. 3x minus 4. Alright, so I go to the inverse function, which is this one. Replace all the x with 3x minus 4. So I'm gonna have, instead of x here, I'm gonna have 3x minus 4 plus 4 over 3. So it's gonna be 3x minus 4 plus 4 over 3, which is 3x over 3, which is x. So they are inverse of each other because I proved both direction. Right, we finished chapter 2. See you later.